Okay. So y is equal to x minus tan of x. I want the derivative. I want y primed. What's the derivative of x? 1. What's the derivative of tan? Secant squared x. Anybody know what 1 minus secant squared is? Oh, you all have different colored sheets. Tan squared? Is it negative tan squared or is it tan squared? Negative tan squared. Okay. It's negative. Whoa. It's negative tan squared. All right. So y is equal to x times secant x. What rule do we need to use here? Product rule, because we have two functions being multiplied by each other. Product rule says derivative of the first function, so I'll call this one f. What's the derivative of x? 1 times the other function, secant x, plus, what's the derivative of secant? Yeah. Derivative of secant is secant x tan x, or tan x times secant, whichever way. So I get secant x tan x times the original function, which is just x. You could leave it like that, or you could, what could I do to this? Or you could factor a secant x out, depending on what they're asking you to do. And you're left with 1 plus x tan x. Whew. All right. What rule do we want to use here? Okay, you can use quotient. Let's do that. Let's use quotient. Okay, what does quotient say? Maybe I should write these on the board. Quotient rule is f prime of x times g of x minus g prime of x, f of x over g of x all squared. Okay, let's do quotient. What's the derivative of the top? 1 minus cos squared, or cos x. So the derivative of cosine is negative sine, but it's got a negative in front of it, so it's just sine of x, right? Because the derivative of 1 is just 0. So I get sine of x times the bottom function, which is sine of x, minus the derivative of the bottom. What's the derivative of the bottom? Cos of x times the top over the bottom squared. Now let's clean it up. We okay? Can we simplify this? What? Yeah. So if you look at this, sine squared plus cos squared is 1. So then I end up with 1 minus cos of x over sine squared of x, which is very similar to what we started with. Now, there's an easier way to do it. I don't know if it's easier. If there's another way to do it, say that. You have a single denominator, right? So that means you could rewrite this as 1 over sine of x minus cos x over sine of x. What's 1 over sine of x? What function is that? So this is cosecant x minus, what's cos over sine? Cotan. So that's the same thing. What's the derivative of cosecant? Negative cosecant x, cotan x. What's the derivative of cotan? Negative cosecant x squared. Right. Oh my gosh. Which then gives you that. You might be saying, is that the same as the other one? It is. If you look at this yellow one, you could write it as 1 over sine squared minus cos over sine squared. What's 1 over sine squared? Cosecant squared. Cos over sine is cotan, right? If you think about this, this is the same as cos x over sine of x times 1 over sine of x. That is cotan, and 1 over sine is cosecant. So they are the same thing. This is the thing about trig, is stuff that looks totally different is actually the same if you rewrite it. Okay? Just be aware, the whole point of this one is when you're doing something, if it's a quotient and it's a single denominator, if you want, you can divide that denominator to both, right? We did it with polynomials, you can do it with trig functions. So sometimes that makes your life a little easier. All right, I'm going to give you a few practice, and then we're going to move on to higher order derivatives. So not page 45, page 125. 45 to 53 odd, 67, 81, and 105, please. I'll give you like a half hour to work on that stuff.